Welcome again to the Southwest Climate Podcast. I guess this would be, Mike, the pandemic version, the first pandemic version. I remember, about a month ago where we were doing it in person and hoping that it wouldn't come to a remote recording, but here we are. How you doing?
I'm good. I quite honestly didn't see this coming, which I'm going to guess a lot of us didn't.
Well, how you making out?
My beard is longest it's ever been.
Yeah, that is.
So it's seeing as yours is too, I think.
Yeah, we are now in a contest, I guess. Looks like you've got a few weeks head start on me. Or maybe,
I had a couple year head start on you, yeah.
It's good to be here. And for our listeners, if you're podcast fans, I'm sure you've been hearing a lot of podcasts recorded over Zoom, but that's how we're coming to you. So if there's a little bit of an audio quality issue, hopefully not, though. We've got the best sound person in the game. Ben will make us sound good and delete all the things that make us sound not so good.
Maybe delete one of us totally. We'll see how that turns out.
Well, we'll do our best here to bring the Southwest climate to people.
The climate has continued.
The climate has continued. So what I thought we would do, Mike, let me throw something out at you. I thought we'd take a little bit advantage of, for obvious reasons, the collective interest in the COVID-19 situation and talk a little bit about the connections or lack thereof with climate, because that's been in the news. Won't spend too much time on that. We're not epidemiologists, so we don't want to stray too far from our wheelhouse, but I think it would be instructive to just think about and talk a little bit about that. And then, we can go into sort of our normal mode of operation and talk about what's been happening in last few months and a look forward. How does that sound to you?
Yeah, it does sound good. I think we've been having some exchanges on Slack and email, and I think you've really been paying close attention to some of the COVID climate, the breaking news, the breaking science on what we're learning about that.
With respect to the climate part of this, I think by analogy, people have been talking about, well, there may be a seasonal signal because there has been seasonal signals that have shown up with the flu, and COVID is not the flu. And obviously thinking about how transmission may ebb and flow as we move out of the Northern Hemisphere winter obviously has pretty important implications, because obviously the Southern Hemisphere moves into its winter. And so there might be some ability to think about what might happen. I think we should also really contextualize this by saying, as in these are systems, and they're very, very complicated. And any one element of that system, be it climate, be it economic, be it social conditions, be it other environmental conditions, are confounded by a whole bunch of other variables. And I really think that's kind of the key challenge right now with thinking through whether or not there is a climate signal. So there was a report that was just put out by the National Academies of Sciences, because they were asked by the administration, well, what's the latest on the science? Because science is in hyperdrive right now. And I think one of the heartening things that I've seen from this pandemic is just how much activity there's been behind the scenes on the science front, on all fronts, like just really wanting to bring people's skills to bear on the problem. And so obviously climate scientists and weather and meteorologists are part of that. And so the Trump administration really asked what the National Academies, what the latest was. And so they did this rapid report. There's not been a lot out, obviously, because it's new. There's been some reports, but mostly in preprint form, which is more or less non-peer review papers, just to get the information out there as quick as possible. But it doesn't go through the traditional modes of vetting, that have looked at some laboratory studies about COVID and humidity and temperature, and some more natural experiments where you actually look at like the case rates across different countries and relate them to environmental conditions, climate conditions, and try to pull statistics. Now, the main take from this is it's very early. It's inconclusive evidence. There's some studies that suggest there is a relationship. There's other studies that suggest that there's not a relationship. And so I want to just pull out what I think is a worthwhile quote from this report. And anybody can download this from national academies. It's like the preeminent scientists get together and they, review what's been put out there and are able to scientifically vet it. The title is Rapid Expert Consultation on SARS-CoV-2 Survival in Relation to Temperature and Humidity and the Potential for Seasonality for the COVID-19 Pandemic, April 7th. Okay, so there is some evidence to suggest that SARS-CoV may transmit less efficiently in environments with higher ambient temperatures and humidity. However, given the lack of host immunity globally, this reduction in transmission efficiency may not lead to a significant reduction in the spread without the concomitant adoption of major public health interventions. Furthermore, the other coronaviruses causing potentially serious human illness, including both SARS-CoV and MERS-CoV, have not demonstrated any evidence of seasonality following their emergence. I guess the point here that I would make is that there is by no means any conclusive results out yet on looking at the links between climate and COVID. And I think we should all plan on doing the other necessary steps to eliminate its transmission and not rely on temperature or humidity as we move into the summer. I don't know. What do you think, Mike?
I completely agree. And I think that us being the Southwest Climate Podcast and me leaning so heavily on climatology, we know that it's going to get warmer. As it gets warmer, the humidity is not going to change a lot. We're going to bottom out in being in very dry and hot conditions by June, which is what we normally do. I think what you're saying is that the climate links with virus transmission are pretty small and poorly understood. So I don't expect that we will see a large climate effect on virus transmission as we go forward.
So there's two types of ways of historically figuring out relationships between temperature and humidity and other of those types of variables and disease. And again, this is epidemiology. We're not epidemiologists, but the two types are, either laboratory.
Not stopping us.
True. We are in that day and age, right, where everybody's a pundit on everything. You can do these laboratory controlled experiments where you actually have fairly good control over environmental conditions. So that's one way. And the other way is through these like natural experiments. And again, this is straight from that National Academies report. And those natural experiments are basically looking at real life data. And what's flawed about that approach is maybe not flawed, just challenging, is that, the data's tough to come by. It's often underreported some places. And same with the climate data. But the other thing is we right now, people want things in real time and they want it really quickly. And for those natural experiments playing out right now, we've only had 4 months into this.
Yeah, it's a novel virus. We don't have enough data. And I think that the actual case rate reporting is way underestimated. And I think that that's widely known too. And I think, like you're saying, the experimentation, there's only so many things that you can do as far as varying environmental controls on that. And they're going to be laboratory. And so how they actually work in the real world, we're living the experiment right now. And I don't think there's enough to go on to be able to say anything particularly meaningful as far as the climate connection right here.
So 2 points I want to make on that. And one is I went back and I was thinking about this and I was like, okay, I didn't even actually understand why there's a seasonal flu signal. So I did a little bit of reading, and it turns out that there was a number of hypotheses about why there was a seasonal expression of flu that wasn't really definitively tested until 2007, believe it or not. And so that made me think, it took what, 100 years or 90 years, basically since the 1918, 1990 pandemic flu for there to be definitive experimentation to find the transmission link between temperature and humidity and seasonal flu. And like here we want it now. Again, 90 years of knowing about a particular virus and trying to go through the science to figure it out. And here, again, we're 4 months into it, if that. So, and I guess I should say, just because I found it interesting, people had hypothesized that, well, maybe there's more cases in the winter because, people are indoors more. And so there's closer contact and more circulation, Or another hypothesis had to do with just less sun, and therefore, people's bodies were producing less vitamin D, or people, had less melatonin, and therefore their immune systems were suppressed. And then, of course, the third one was the link between that the actual virus survived better in cold and or drier conditions. And it turned out that this was, so some scientist in around 2007, when he published the paper, was like looking at old 1918, 1919 papers on the Spanish flu, and found that somebody had made a reference to guinea pigs getting it. And part of the problem that they had prior to this in testing those hypotheses was they couldn't really test this on living things. Can't do it on people for obvious reasons. But it turned out guinea pigs became the guinea pig, and they could actually that they did catch the flu virus. And then this guy set up this nice experimental design and was able to measure differences in transmission under different temperatures and humidity ranges, and made a strong link between transmission rates and environmental conditions. Anyway, I guess the point is we still got a long way to go. I don't know, Mike, you and I have been sort of going back and forth just related to the need for quick science and how that can inform decisions, and how that really puts strain on the traditional scientific vetting process of more protracted peer review, which quite frankly is perhaps in some respects not quick enough for the current situation. And so you get these preprint studies that perhaps could put out, and there's been retracted studies, and there's been abuse of studies related to this virus just by looking at preprints that haven't gone through the scientific process.
Yeah, science doesn't move quick by by design.
You got no hot take on this one, do you?
I think science has a really important role in all of these kinds of globally impactful type events, but it usually is somewhat secondary and at a slower pace. And it's often not like the disaster or pandemic movies where the hero is a scientist. I just think that's, more.
Oh,
I love the movies about like volcanoes are about to erupt, and the protagonist is always a volcanologist. I always wanted to be that. I was actually thinking about Pierce Brosnan in that volcano movie, where he was trying to tell everybody that the volcano was going to erupt and nobody would listen to him.
I haven't seen that one.
That's the Southwest Climate Podcast, is we're trying to tell people to listen to us that it's going to be dry in June and hot, and nobody will listen to us.
Well, that is the easiest prediction to make. If there's ever a prediction you want to bank on, it's that it's going to be warm and dry in June in the Southwest.
You heard it here first.
Okay, well, that's good. I think that's a good transition. Anything else that you want to say about before we move on? Anything that the climate?
No, I think it's good, and I apologize to anybody who's looking for respite from a COVID discussion.
Maybe we'll put in the introductory text to skip ahead if you're all COVIDed out.
Honestly, Zach, I think it's going to be an interesting thing I give it a year from now. I think 18 months from now, that's when I think we can have a pretty interesting discussion on this. When we've seen an annual cycle go by, we've seen the case reporting get better. We've seen people actually able to do some meaningful statistics. Then I'm going to be more interested in kind of diving into this.
Yeah, and I'll be interested in see if there is a signal, like what the effect of that signal is amongst all of the other things. And I think what usually plays out is, the response, like the human agency and the actions that are taken will be much stronger. And this is kind of an obvious statement, but there'll be much stronger determinants of transmission than, a few degrees or even like 10 degrees Celsius Fahrenheit. So we also have to think not just if there is a signal, but what's the relative strength of that as well.
Yeah, it's just a little bit of we're trying to find some hope right now, and the hope we have is that the sun angle is getting higher in the northern hemisphere. So that's what we're latching onto right now, and I don't think it's something that we should hold real tightly to.
Right. Yeah, we all want this to end quicker than not. But okay, so let's move on. All right, so we're now mid-April, effectively have the winter precipitation in the rearview mirror, with the exception of maybe a rogue late April, early May storm. I think we can feel fairly confident that what's come before is what we have. And Mike, in terms of precipitation, it was pretty darn good.
Yeah, it's been quite good. That's two Aprils in a row. I think we can say that.
Right. So, okay. So if we look at just around the Southwest, Phoenix, this is data that you've plotted up, Mike, and it looks at the entire winter plus a little bit of, if you don't want to call October the winter, it has October in it. But in the Southwest,
it didn't rain in October.
It didn't rain in October. Yeah. Okay. So the October through end of May, and we're not there, obviously, precipitation so far has been in Phoenix, we're at like 5.8 inches, which is, 4.25, 4.5 is the average. So we're above average, even if we stop right now and we still have a little bit of time to go. Tucson, above average as well, 5.6 inches, and around 5 is the long-term average. So good there. Flagstaff, above average, 15.2 inches, where a little over 14 is the average. So again, above average. In Albuquerque, above average, and El Paso, above average. So pretty comprehensively, a good winter. So Mike, why don't you take us through maybe what's just happened in the last month or so? How did we get here?
I think that we last talked probably March 9th or 10th. Right at that point, we had fairly decent activity February into early March, and we were just on the cusp of it, the weather turning unsettled again. And so it had been quite an interesting evolution of the weather pattern through March. And it was not all that unlike what we saw in February, and it kind of continued into the rest of the month, even into an event that we had across the Southwest last week. And one of some of the predominant patterns in the Northern Hemisphere this entire winter have been a strong positive Arctic oscillation, which has, kept all of that cold Arctic air bottled up around the poles. So we haven't seen a lot of cold air outbreaks in the eastern part of the US. And what we've seen in the eastern Pacific Ocean is a pretty strong ridge of high pressure. And that has led to this strong ridge of high pressure leading to its pretty consistently negative values of the Pacific North American pattern, which is it's a pattern of highs and lows in the eastern Pacific through the continental U.S. that the Northern Hemisphere can kind of get locked into. And so it's a common weather pattern, which is why we've given it a name, and we've actually calculated an index out of it. And so the positive phase of that Pacific North American pattern, which would be a strong trough of low pressure over the Bering Straits, which would lead to a ridge downstream over North America, and then sometimes a trough developing or a subtropical jet developing over the southeast. We've actually had the exact opposite pattern, which is that strong ridge of high pressure over the East Pacific, and then kind of a persistent trough either over the western U.S. or just off the West Coast. And having that persistent pattern has led to this weak instability that has slung or even spawned these little mid-level low pressure systems. And so that has led to some pretty slow moving low pressure systems off the Southern California coast that have led to some pretty heavy rain events, have funneled up some subtropical moisture into the Southwest, Southern California in particular, this last event that was in early April. But in mid-March, we ended up having a couple of those events just slowly move across the Southwest. And they were warm events and brought quite a bit of precipitation to much of the state. I was pulling up some of the data. The Southwest part of the state, pretty interestingly, has had just enormous amounts of rain for March. I pulled up Yuma, the Yuma Proving Ground had 2.75 inches of precipitation in March, which I believe is their record, at least back to the early 60s, the previous wettest March on record for that station was 1992, which is an epically wet year for the Southwest. So pretty interesting to have the low deserts get that wet in March.
Yeah, and that March event really gave Phoenix quite a bit of rain. It was something like there was measurable rain at the Phoenix Sky Harbor Airport for 4 consecutive days.
Yeah, it didn't lead to much for Tucson. I mean, Tucson they did well in that particular event, but I think we only got like half an inch out of that event.
Yeah, it was not as much as it seemed like. It was more of a northwestern signal for that particular event, but nonetheless.
Yeah, right. I
mean,
think that funneling into that precipitation gave it a pretty hard edge to the southeast. And you're right, the central lower desert part of the state did pretty well with that event.
But and then looking at Tucson, I mean, consistently since the winter more or less started in mid-November, I mean, there's been a constant drizzle of rain. I mean, not a ton of large events, but that's not uncharacteristic. It's just been, it seems like if you're reading between the lines on this bar graph here, you can almost just see a number of these low pressure systems wafting down from the north and providing, some nice moisture, every week or so for the most part. I mean, we didn't have it from mid-March, previous to mid-March. I mean, there weren't many long breaks in precip-free periods.
Yeah, it's interesting. So I was looking at the cumulative precip for Tucson, and then you can look at Albuquerque too, which is pretty interesting because it's not necessarily close to us, and it's due northeast of here. But if you look at November to present, I'm just saying what you're saying here too, is that the accumulation of precip and the spacing of the events is as quote unquote normal as you could get. It's just like the pace of the precipitation puts you as close to the average accumulation line as you could probably get in any year. And so Tucson, rounding out the October through May period is 5.63 inches. And that's just a touch above what you'd expect over that period anyway. And the number of events has been 29, and I think you expect to see like 26 events. And the average intensity has been right around 0.2 of an inch. So it's like as mundane as possible. And if you look at the temperature patterns too, we just didn't have any long stretches of either exceptionally cold or warm weather with that pacing of the precip too. It just kind of kept everything in check. And so it's as boringly close to climatology as you could get.
Yeah, but we'll take it.
Oh gosh, I take this every year. It'd make our job so much easier. If
you zoom out and look at the West, or even look at the continental US and look at the accumulated precipitation over the winter, the Southwest fared as good or better than most of the country. And in comparison to the West, I mean, you go north of San Francisco all the way, north along the coast, and it's the opposite situation there. It's the hinge line basically has been at San Francisco. Northward, it's been dry, and to the south of that, it's been wet. So we really fared quite well from a pattern that brought us more events than the Pacific Northwest. So I'm wondering that. Do you know? I mean, was the synoptic pattern it just so that the ridge was pushing the storms slightly off the West Coast, and then they were slipping in underneath sort of Northern California into our area? I mean, what would have caused that pattern?
No, it's exactly it. It's you just look at the kind of the sequence of all of the precipitation. I'm sorry, I keep losing the page that I'm looking at right here. That ridge of high pressure in the East Pacific is unfavorable for the storm track for the Pacific Northwest and is more favorable for us. I mean, they ended up, it kind of wobbled around again. This wasn't a super strong, I don't think, blocky type pattern. It still wandered around a bit, but if you look at the anomaly plot, just the average of all the weather maps for like the last 30 or 90 days, it's definitely that the predominant pattern was that ridge in the East Pacific. and a weakness of across the Southwest. So it really did favor us. And again, the trajectory of some of those storms, the speed of some of those storms, and their ability to tap into subtropical moisture was really important for a lot of the events we saw in February and March, especially those heavy rainers we saw in March.
And by speed, you mean they weren't moving fast.
They were not moving fast. No. If you look at the maps, they're not quite cutoff flows. Some of them are, but they're not wandering around for days and days. They're actually just slow moving, closed, low pressure systems that were forming off of a wave pattern that was moving across the Western US.
So can we chase our tail here and ask the question and answer it if there's anything that was causing the slow moving? I mean, there's
probably an answer. One aspect of it too is that the predominant polar jet was actually quite a bit further north because of that, or at least associated with that positive Arctic oscillation. And so these wave patterns were they looked like they were breaking over the west and leaving some of these little low pressure systems behind, and then they were getting absorbed again into the mean flow. I'm just looking at the maps from early March through present. Mm-hmm. And so it's not like a real deep trough of the polar jet dropping far south in the Western US. It's more of a wave breaking over the west and then leaving a low pressure behind, and then that low pressure getting picked back up again.
Right. And so those low pressures are sort of outside of the main jet stream. And
yeah, exactly. Right. Right. It's not a deep car. These are not, and that's also what we saw too, is they're not super cold storms. It's not got this channel of high latitude cold air diving south. It's more their little kind of weak mid-level low pressure systems that were kind of shortwave troughs moving across the west. That's a whole lot of jargony and
made perfect sense to me.
Yeah, seat of the pants. Looking at these weather maps in real time. I mean, I'm sure there's a good quantification for it. Again, I just went back to the indices to see what, if there's anything that's sort of really standing out as being, predominantly driving it. The Pacific North America pattern, I think, captures some of this. And the El Nino, we've been weekly warm, but I don't think that's been a strong driver.
It's kind of been teasing borderline weak El Nino, but I mean,
and I don't
sort of an arbitrary at this point. Even if it were to cross the numeric threshold and become officially ranked in El Nino, which I still think that's in play. I mean, it depends on the sea surface temperatures of the next few months, but it's fairly arbitrary. What's the difference between, the average sea surface temperatures being, 0.45 and being classified as a neutral, and being, 0.51 and being classified as a weak El Nino. So maybe it's
right. It's this whole thing. Is it helping or hurting? I don't know. Probably not. Yeah.
It makes it hard to attribute. Yeah.
The attribution is this is pretty challenging stuff. And I think both you and I try to scour the discussions, and the ones that I've looked at there's no real strong single cause. I mean, it seems to be weather variability, at play.
It is interesting though. I mean, the Western pattern looks very El Nino-like.
It does. Yeah. I mean, it's certainly got that hints of it. And I think I think you could connect that back to some of the things that you see with a Pacific North America pattern. Like that looks pretty similar to what you'd see with that kind of predominant weather pattern, except for there's kind of the Texas, you'd be a little bit wetter in California. I'm sorry, not California, Florida. I went all the way to these. It's interesting, for March, Florida largely had its record driest March. And so the wet was from Southern California through Southern New Mexico and through Texas, and then kind of went up through the upper Midwest. And so there's no good, perfect, I think, attribution here of any single source. too. And I think that, our kind of mundaneness, it doesn't totally communicate the broader story, because I think that you and I have probably seen some of the reporting coming out, but February marked the end of the second warmest winter on record. March 2020 was the second warmest March on record too. This is globally. So, what's happened here locally is pretty different from the global pattern.
Yeah, about those rankings, I pulled up this percentile figure for the last since January 1. So January 1 through April 1. And you alluded to this when you talked about Yuma getting record precipitation. But in the Southwest, Yuma, I think, is in the 99th percentile. Phoenix is in the 84th percentile. Prescott, the 75th percentile. There's a few stations up in the sort of Four Corners area. What is this one? Winslow is in the 90th percentile. Deming, 87th percentile. So really wet conditions in this 3-month period. And then as you move away from the Southwest, wow, it looks like San Francisco was the third driest on record. Many of the stations in that sort of area are in the driest 20 percentile, and so we fared in our area. We fared quite well.
Yeah, we had nothing to go on, right? Coming into this winter with no strong El Nino, La Nina signals. So it's nice when they kind of shake out on the positive side like this.
So, we talked a lot last podcast about snowpack. So let's revisit it here. It's, one should say, at this time of year, you can actually get quite a bit of variability among stations. If you look at stations that are close to each other, just by virtue of it warming up and the elevation at which those stations are. And so obviously the stations that are at sort of moderate elevations are going to experience much more rapid and sooner melting than others. So when you look at, station data at this particular time, there's quite a bit of variability, but nonetheless, the pattern is still one where the Sierras, for the most part, are, if it wasn't for a late, when was that storm in early April, right? Where it really sort of saved part of the northern Sierras. Do you recall that, Mike?
Yeah, that's right. Yep. I'm just agreeing with you. Did you want more quantification than that?
No, agreeing is fine. I think that works better for me.
Yeah. Yeah. It was on April 5th, 6th, and 7th. And even into the 8th it was one of those we were just talking about earlier, was one of these slow moving closed lows, came right in over Northern California and settled in over the state and brought up quite a bit of precip to the Sierra.
Yeah. So it's a mixed bag on across the West on what the snowpack conditions are, but they largely reflected for the most part, where there were in the Central Rockies, where there were more precipitation events than there were in the Pacific Northwest, for example. And the Sierras were the big loser, which we talked about for the most part last podcast. Do you have any other insights about snowpack?
Yeah, so I just pulled up the snow water equivalent estimates for the Upper Colorado River Basin through the SnowView tool here that some colleagues put together here at U of A. And really, really interesting to look at you can pull up a plot of the cumulative precipitation for the basin, and then you can look at the estimate of the snow water equivalent for every day of the year. And just as we were talking about earlier, what happened in 2019, it almost perfectly hugs the median curve for snow water equivalent. And so it was a little bit above in February, and then has fallen to almost on top of the median. And so as we get to sort of April, we get right to now. So this is of April 14th, the average snow water equivalent for the Upper Colorado River Basin is right on top of the median. So pretty close to climatology.
Yeah, but we should also say that the projections for stream flow, which usually often mirror to a large extent the snowpack, are actually calling for slightly below average conditions.
Yeah. So we talked a little bit about that last time. So what do you think is causing that kind of divergence between the two things?
Largely has to do with when the precipitation occurred and the warming conditions.
I think it had to do with the early dryishness too, the fall dryishness for parts of the basin, that the melt was going to go into charging up soil water before it turned into runoff. So I think that's part of what the models are probably still picking up.
That's right.
That didn't go away.
Right. Relatively dry soil moisture early on, more evaporation with the warmer temperatures. I mean, it's not the numbers aren't much below average for the upper Colorado River. Sort of the mean guess, or the best estimate, is that 86% of average stream flow for this year.
It's kind of the best you could ask for, right? Is that if you're going to get something that close to climatology with some of those other competing effects early on in the season, to counteract those, we would have needed to gone way above climatology to get above average or above median runoff, right?
Yeah, and when you come down more toward the Salt River Basin and the Verde River, the projections actually go up. And so, the Colorado River may be below average, but the reservoirs in the Salt River are near full. Salt River, the Roosevelt Reservoir is 97% full. The Verde reservoirs are about 100% full. So that's a pretty good sign. The best guess is not above average, but they're near average, 96% for the Salt River near Roosevelt for the January-May period. So we won't complain about that, I guess. Verde River, on the other hand, is above average. Horseshoe Dam, best guess is around 118% for the January-May period. So again, this is what we would expect given the precipitation that we experienced. And we had some warmer than average temperatures and some dry soil moisture, but the good rainfall, the constant rainfall, certainly makes the water situation a pretty good picture.
Did you happen to look at anything for the upcoming fire season? So my expectation is we've got 8 weeks till monsoon start.
Woo-hoo.
Happy 8-week countdown. So June 15th is 8 weeks away. And the significant wildland fire potential outlook has been issued, and it was issued on April 1st by the National Interagency Fire Center Predictive Services. Actually has southeast Arizona and the central part of Arizona is above normal wildfire potential. And so my guess is that the epic wildflower season is going to turn into a nice crop of fine fuels for the next month or two.
I'm not looking at that map, but is that also at higher elevations? Like, are they calling for above average fire conditions in the higher elevation zones as well?
No, they aren't. So I didn't pull up the discussion here, but this kind of looks like, and it goes away by July. So I think the expectation is that monsoon shows up on time. Again, I did not make that forecast. That was not my forecast right here. I'm just looking at trying to interpret.
That would be the best estimate, though. No, but that would make sense because, wet winters, would produce more fine fuels, and it doesn't take long to dry out these fine fuels. I mean, and we're headed right into the meat of our hot season, and, just give it a couple days and what those grasses and shrubs, become, fine fuels to burn quite easily. So how do you have a season where it's not above higher risk for fire in this particular period at lower elevations? I mean, I would just think that it's always going to be high risk.
No, it's actually interesting. If you look at the research on this, and I feel like I can actually talk about this because I did it some of my dissertation, but the fine fuels actually do come and go in the low deserts. They don't have it'll vary between perennials, grasses, and annuals in the low desert, but they don't tend to hang around for many, many years, right? So they can be tied pretty tightly to having a wet winter in the low deserts, causing a crop, and then having that standing crop of fine fuels be available. But they can break down once they cure out, they'll break down pretty quickly, and then that risk will go down. So if it ends up being a very dry winter, you don't end up having a lot of annuals,
Right.
and then that will, the risk is low. So this past, so we had super bloom conditions a year ago because we ended up having the really wet October with the tropical storms.
Mm-hmm.
That early part, that late fall, early winter tends to produce a lot of annuals. And so we ended up having that in 2018, 2019. And then the timing of the rain in November was really good for pushing another crop of it. So I think that's some of the concern here too. So Southeast Arizona, though, is a little bit more warm season perennial grass, and they did not have as good of a summer last year with the monsoon. So that might not be as high as a risk as it would be the lower desert areas, I would think.
It does matter when the winter rains come. So
yep.
You could have an okay winter, let's say a 75% of average when you look at it over, the 4 or 5 month period. But if those rains come in November or December, that is still creates good conditions for fine fuels. How does that work? I mean, we tend to think of these in gross terms, like above average winter, but what's the timing? What's this?
So the correlation between the fine fuels and annuals, it really peaks with the timing of the rain in November, December, and January. So if you got the same amount of precip, if you looked at the October through March total precip in Western Arizona, you can have years where in that total, the total was the same, but the outcome on the ground was really different just based on the timing of the precip in those seasons. And if it's shifted more earlier and it's sustained early on, then you have got a longer, because it's like planting a garden, right? There's a growing season, and when you water the plants, by the end of that season is going to be how big they're going to get, right? So if you ended up in the October through March period and it all came in February and March, you're going to get a pretty different outcome than you would have gotten if you would have done it in November, December, and then maybe again in January and February.
And that's kind of the worst outcome for fine fuels. Like if it comes late, like you want it to come early and often. Well, what's worse, coming early and then shutting down, or coming late and not coming early?
Well, I think you can grow again. This is where all the different ecosystems are kind of tuned up to the different timing of precip. In the low desert, that is, again, you're kind of leaning towards the Mojave here, where they're tuned up towards winter precipitation. If it comes early in the fall, then you can get stuff to sprout. If it gets hot and dry, you can truncate that growing season by the time it gets to be January, February. But if you can do something like we did this year, which is start early and go often, you're going to get the best outcome for fine fuels in the low desert. And again, we're talking about wildflowers here too, right? So your best outcome for wildflowers is going to be native wildflowers down here is going to be early and often with the precip rather than a lot late.
Yeah, and it's been a pretty good wildflower season. I don't know if you've been out, but
we got lucky, and we've got this penstemon crop in our backyard that continues to reseed, and this year was epic because of, I think, the timing of the precip and the background temps.
Yeah. So okay. So I hadn't looked at the fire. That's something to keep an eye on going forward. And we've now got, like you said, eight weeks prior to the monsoon starting. So we are heading into the heart of the fire season. So we'll do a little bit more on this in a month, see how things have evolved. Anything else about Mike, about the upcoming sort of hot and dry season? It's in my mind, it's kind of the most uneventful time. It's also the most depressing time, which will also be worse this time around because we're in our houses.
That's right. This is just me being wish casting at this point. It's not crazy to think that we might end up having maybe one more precip event. I think what's more likely is we'll end up having some windy days as we transition here. I'm just looking at the 2-week forecast, and it doesn't necessarily lean in any direction. There's not a lot of indication, in the week 3-4 forecast too is equal chances as well. So there's no strong signal in either way, but you're right. We're running out of time.
If you look at the average, I think there's on average, less than 1/4 of an inch that falls from now until the end of May.
Oh yeah, for sure. We did, again, wish casting. We had a 1/2 inch, and remember how cool
that rogue storm. I love that.
Totally weird. Yeah. No way we should ever count on that.
What I want you to do now for the next podcast is come with your best prediction. I want to thought through monsoon prediction based on mechanisms. Give me some reasons for the monsoon to start earlier or late. And if you say it starts on time, then it'll be a short conversation.
No, I'm excited. Like I feel like if we're quarantined now and we're kind of looking for something. There's no sports on. There's nothing. It's like the monsoon season will have to be our sport.
Oh, we have to turn that into a sport. That's a great call.
Yeah, and so I really think we should be serious about the fantasy forecasting this upcoming season and see if we can try to open this up a little bit more and kind of be more frequent about our sort of discussions and engaging folks on this.
Yeah, we gave that a trial.
Oh, we got going for us.
Yeah, we gave that a trial last time. We did. We can do it better though. We'll make that promise.
We might have more time on our hands this year. I don't know.
Well, I think that leads into just thinking a little bit about the future, maybe not just the monsoon, but also a little bit longer term with the El Nino, La Nina conditions that are on the horizon, since we always do this. And I think maybe, Mike, the only real interesting tidbit to say about El Nino and La Nina is that there is some hint that the models are tilting toward a La Nina. And of course, this is the time in which it's the hardest to make predictions. So I pulled up some statistics about, at this moment, how much correlation there is with current data and wintertime projections for ENSO. Okay, so let me see. I'm going to test your knowledge here. In April, what do you think the R squared is, the correlation, the amount of variability explained by April data for the November, December, January ENSO forecast?
0.15.
0.15. Okay, so it changes depending on if you're looking at statistical or dynamical models. So for dynamical models, what 0.15 is your answer, or does it change?
It's probably 0.2 for dynamical and 0.15 for statistical.
It's pretty close. It's actually a little bit higher for dynamical.
Oh, is it really?
Yeah, a little under 0.4.
Oh, wow.
Statistical models are like less than 0.1. So basically, I mean, you can't hang your hat on anything there. And even 0.4 is pretty darn low.
Right.
People often call this the spring predictability barrier, and those numbers increase through time, through these months. And so let me test your knowledge. In October, if you were to make the forecast with October data for the November, December, January period, what do you think the percent variance explained is?
For statistical or dynamical?
For either. Let's start with dynamical.
0.7?
It's actually it's higher than that. It's like,
is it really?
It's like, I'm eyeballing it here. It's above it's probably 0.9-ish.
Well, okay, fair. Okay. That was dumb of me to say 0.7. That's almost a nowcast at that point.
It's the next month. It's the next month.
It's almost a nowcast for a slowly evolving phenomenon.
Oh, so you think it should be better?
It should be better. That just means the monitoring isn't very good.
Yeah, but if you go to September for the November, December, January 3-month season, it's still above 0.8.
Again, it's a slowly evolving phenomenon that has a seasonality to it. So if you're almost into the season, the money shot is July, right? Is like when you're not quite sure how it's going to shake out. and you still got some lead time to make some decisions.
So that's interesting. So July then is about 0.7.
Okay. That's what I would have expected. And that's not terrible.
And what else is interesting, I think, is that there's virtually no difference between just looking at statistical models and looking at more sort of computational numerical dynamical models. All right.
I wanted to just kind of bookend the conversation. I wanted to see with my own eyes what the model prediction plume looked like for ENSO going forward. And I have was the April one out? The ENSO quick look. It looks pretty neutral-ish to my eyeball regression. I don't know about you.
Well, yeah, I mean, so both a neutral and a La Nina has slightly higher odds than their sort of climatological probabilities, where the El Nino is a reduction, obviously. So the neutral and El Nino split the percentages from El Nino. But yeah, I mean, it's like we just said, it's sort of a flip of the coin at this moment.
I see now what's going on. Ben slacked us the NMME, National Multi-Model Ensemble, all the ensemble output here in the climate forecast system. The NOAA CFS model just craters over the next 6 months or so.
Right. And what I was just saying, though, is sort of looking at the ensemble, looking at all of them together and trying to come up with probabilities based on all of the different models. But any one individual model may have a different outlook. And the CFS is the sort of NOAA preferred version, NOAA preferred model. But yeah, that is...
I've been hurt by the CFS2 before, though.
No, but this goes back to what we were just talking about. At this moment, it's give it a few months before these things can flip quite vigorously at this moment.
Yeah. This is a novelty conversation to have. It's not a particularly useful one at this point.
That's right. I mean, it's just a tease, like stay tuned. We'll talk more about ENSO as we have something more definitive to say.
I guess the most useful thing we could probably say is that we've struggled with trying to understand the effect of ENSO on the monsoon season. So I think maybe the upside is that there doesn't seem to be there's not a strong event underway that would mess with the monsoon season if there is indeed a messingableness with the monsoon season with ENSO.
Yeah, and that is actually a good point, because it wasn't so many years ago during, I believe it was the first dip of the back-to-back, like really strong El Niños, where that El Niño did evolve early in the summer.
Even last spring, we had weak El Nino conditions that collapsed in the spring. And there was some concern that was some lingering impact that ruined our monsoon start and really suppressed monsoon activities. So maybe we can have that noise off the table for going into this season.
Well, great. We look forward to having you talk us through why you think the monsoon's going to be better or worse than average next time, Mike.
But you know that I'm always going to be optimistic about it, so it won't really be a reasonable, rational conversation. It'll just.
I want a psychological explanation.
I can't do. I will need some meteorological therapy prior to that, so I can be an even, unbiased discusser of the upcoming monsoon. But I'm too enthusiastic about it.
Okay, Mike. Final parting shot. What's your take home from the winter? Any lasting thoughts on this winter?
Boring, just like I like it.
Boring, really?
Well, climatological, just like I like it. No, it wasn't. I mean, it was. Just every 3 to 4 days or every week or two, you get a precip event. Kept the temps down. It grew all sorts of great flowers in our yard. Hey, I'm very, very pleased.
See, that's what stuck out to me. It was the frequency of it. And I don't know if that was all that unusual or not, but
it's been very, very unusual if you look in the last 5 to 7 years with some of the just crazy hot and dry
swings,
either falls or springs or both that we've had to kind of weather. And this year just didn't have it. It's
good that we came out of this with a little bit of optimism, I think. So, Mike, As always, it was a pleasure seeing you over this time over Zoom.
You too, Zach, and keep that beard going. We'll have a beard.
Are you going to shave your beard?
Nope. I'm going. This is going to be a full quarantine beard. I've already committed to it. I can't. As soon as everything's lifted, I probably will.
Yeah, I mean, you're going full ZZ Top here.
Oh no, it's growing out in every direction. It's going to be, if it grays out, I can play Santa at Christmas. I will have that gig going for me.
Yeah, but, it's pretty silver.
It's on its way for sure. Thanks for leading the charge today, Zach, over Zoom. We appreciate it. And Ben, thanks for the editing of this crazy file that you'll have to do.
All right. Well, thanks everybody for listening, and stay well. And hopefully we'll have some better news come a month. We'll see. Things are changing quite rapidly.
Yeah. Stay well, everybody. No, it's not the lower. My geography is not great. The upper Colorado River Basin.
Geography? Isn't that where you got your degree?
Yes, it is. Should actually have that. Should have that nailed. The where. So I'm looking at the snowpack